So here's another example of L'Hopital's rule. As you see, I've got x going to 1 this time. If I stuff in the 1, I've got sine of 0 over 1 plus 1 minus 2. So this is of the form 0 over 0. So I can go ahead and take my derivatives for L'Hopital's rule. Derivative of sine is cosine, so I got cosine of x minus 1. And then down here, I'm going to have 3x squared plus 1. Okay, so if I put in 1 now, this gives me a number, right? Because I've got cosine of 0, and then I've got 3 plus 1. So cosine of 0 is 1, so my answer is 1/4. Okay, so very straightforward. Now, one thing I wanted to point out is that for some of these, we've seen stuff like this in the past. Right? So we've done, well, it was actually this one. Was the one I was trying to write up. But it doesn't matter. It's actually the same, right? It works the same. So we did these back in chapter 2. And we did these by factoring and simplifying. You can still do them that way. It's perfectly fine. You also have the option now of using L'Hopital's rule because you can see this is going to be 0 over 0. And so if I do L'Hopital's rule, 1 and then 3x squared, and then that gives me my answer, which would be 12. Right? So you can do that now too. The only time you can't use L'Hopital's rule, and even on the final exam, if they give you that, unless they specify not to use L'Hopital's rule, if you did it that way, you'd be okay. The only time you definitely can't use it is when you're like using the definition of a derivative. Then it will not be acceptable. But if it's something like this, I think they probably will accept it. I will double check on that. Right, now one other thing, next thing about L'Hopital's rule, it was stated as x going to a, but it's also true for x going to infinity. Okay, so for example, let's see what I have here. E to the x over 10 over x cubed. So all of the ones that we had so far were of the form 0 over 0. This is one where it's of the form infinity over infinity, right? So you got this infinity and that infinity. So what's going to happen? And I'm going to infinity. So I just go ahead and I take L'Hopital's rule. And in this case, I might have to do it a couple times, right? The derivative of e, this is 1/10 e to the x over 10. And then this is 3x squared. So let me just clean that up a little. This is going to be 1. Oh, this is going to be e to the x over 10. And this is going to be 30x squared. Fine. Again, it's still of the form infinity over infinity. Because e to the infinity just gives you infinity. I don't want that there. Okay, so I'm going to do it again. One-tenth e to the x over 10. And then this would be, what's 3 times 2 is 6, right? So far, I'm going to clean that up. Put my constants together. 1 over 6, I got 600x. And then e to the x over 10. Still infinity over infinity. But you see my powers of x are going down. So I feel like the next one is not going to be a problem. Then we'll be done. Right? Because in the end, the top is still going to be 1/10 e to the x over 10. The bottom is just 600 because the derivative of x is 1. So this is 1 over 6,000, well, or just e to the x over 10. And now I've got infinity over a number. So that's just going to be infinity. So this limit goes off to infinity. And just for some kind of idea of getting some, what can I say, intuition for this sort of thing, e goes up very fast, x cubed goes up fast, but it doesn't go up as fast as e, right? Because exponentials grow extremely rapidly. So what you're really doing when we're looking at this ratio and this ratio as it goes to infinity, we're asking which one goes faster. Does the x cubed go faster? Because if the thing that goes faster is in the denominator, it'll take it to 0. But if the thing that is going faster is the numerator, it will take it to infinity. So that's kind of the question. You can think about it that way, and you can see how it pops out in the math. Because even after taking the 3 derivatives, the x goes away, and now, but you're still always left with this exponential. The exponential is not going to go away. All right, let me do one more with the infinity. Because that one was kind of long. I think this one is not so long. I mean, let's see. Though it might look scary, it's one of the ones that maybe looks a little bit more unusual, but so this one might maybe look bad to you because it's got an inverse tan, it's got an e, this is e to the minus x, and an inverse tan, and it's going to infinity. So let's talk about that, but in fact, we should know because we talked about it, right? We talked about inverse tan, and what inverse tan does is it goes to infinity, right? If I draw the inverse tan function, it's got those two asymptotes, pi over 2 and minus pi over 2. So as my x goes to infinity, here, inverse tan of x goes to pi over 2. So my bottom here is going to be pi over 2 minus pi over 2. And the top is e to the negative x. Well, you know e to the negative x looks like that. It's going to 0. So this is, in fact, a 0 over 0 situation. Okay? So now I know I can use L'Hopital's rule. Let's see what we get. Oh, phooey. No, okay, it's okay. All right. I did think it wasn't that hard, and I'm like, what? Okay, so this is going to be minus 1 over 1 plus x squared, right? So let's clean this up. These minuses cancel. What do I have? I have limit as x goes to infinity of 1 plus x squared times e to the negative x. Yeah, that's not good. Yeah, that's not good. This, we'll have to come back to this. Right? Because now I actually have a problem. This is infinity, and this is times 0. Okay, we're not going to come back to it. We're going to do it. I'm just going to tell you how to do it because I don't want to come back to it. But this is a different kind of form, right? This is also an indeterminate form, infinity times 0. And you'll have to see the next video to see more examples. But let's do this infinity times 0 now. If you've got infinity times 0, it's not in the right form for L'Hopital's rule because we need a quotient. So we're going to make it into a quotient. So this one's easy to make into a quotient. You got e to the minus x here. So let's rewrite this with the x, e to the x in the bottom. So I've got 1 plus x squared over e to the minus x. Okay, so then, nope, e to the x, right? Because e to the minus x, I write it as 1 over e to the x, so we have this. Now I have infinity over infinity. Okay, now I use L'Hopital's rule again. I'm going to get 2x over e to the x. I still have infinity over infinity, right? Do it again. I have 2 over e to the x. Now that goes to 0. All right, so that was more complicated than I expected. For some reason, I thought it just turned to 1 in the, I don't know what thing. Anyway, so that's the answer. Let's talk more about these different kinds of indeterminate forms besides the 0 over 0 and infinity over infinity.